Hi everyone, in this video we are going to tackle the graph questions in the chapter of kinetics, which is one of the things that a lot of students have difficulties with. So imagine I have this graph over here, right, where I have this standard reaction of A plus B gives me C. If you have not watched the pseudo-order reaction video, you should watch it first. So in this experiment, I want to study A on its own. So rate is equal to K A raised to the power A times B raised to the power B. And what I'm doing here is I'm going to keep B constant either by using it in huge excess or when B is a catalyst. And so what I'm going to get is K prime A raised to the power A, where K prime is equal to K multiplied by B raised to the power of B itself. Okay, and this is the reaction that we are looking at. So over here on this axis, I have time, and here I have the concentration of A. So there are typically two different types of graphs that we usually see in the A-level syllabus, which is the zero order and the first order graph, right, where we have concentration of A versus time. And what we'll realize is that for the zeroth order and the first order graphs, okay, you will get these two shapes. For zero order, it will just look like that. This first order, you will look at this, and it has constant half-lives. Okay, so you'll see constant t half. So if you have the first, if you just simply look at one of the graphs, you'll be able to get zero order or first order, depending on whether it's a diagonal line or whether it's a curve with constant half-life. So for example, in questions, you will usually see two different curves like that. Okay, and these two different curves will give you a concentration of B in this form. And so what you should do at the start is to first, step one, right, see if it's a pseudo order reaction. Okay, so how do you ensure there is a pseudo order reaction? You want to look at the concentration of B, which is X, versus this value, let's say is 0.1. So the value of X must be bigger than 0.1, way bigger than 0.1 for it to be pseudo order. So B is in excess. So this is the equation that we are looking at. Then step two, we just look at one graph. All right, any one graph, and then by the shape itself, it will tell us the order with respect to A. Okay, so we can either look at this graph here and this graph here. As long as we can look for a constant half-life, then we'll know that it's first order with respect to this A here. So don't be confused by the number of graphs here, just look at one. Then the second thing that we can do after this is we can study the order of reaction with respect to B. Okay, and so this is where we look at our rate equation now. So now we ignore the pseudo order reaction, we just look at the main equation here, and you'll realize that we can use the initial rate method. So the step 3, we can use the initial rate method, and we know that initial rate is the gradient at time is equal to 0. So when we take the gradient and we realize that this gradient over here, so gradient 1, right, is half of that of gradient 2. And we notice that we started off with 0.1. We can actually do our simple calculation here. So let's say this is equal to half y. This is equal to y. So we can take two of these equations here and we just get the value of half y over y is equal to K times the concentration of A is 0.1, which we already know is first order because has a constant half-life, multiplied by B, which is X to the power B, and this is 2x to the power B. And what you'll realize at the end of the day is that the value of B is equal to 1. So this is using the initial rate method to solve it. But we can also use another method, which is called the half-life method. So basically what you realize is that in this equation, all right, if we take a look at our t equation for half-life, we will get t half is equal to ln 2 over k. But in this case, since we are looking at this equation of rate is equal to k prime a to the power 1, so this is k prime instead of k, because this is the equation that we are looking at. Okay, and so this k prime, as we have written out just now, it is k times b to the power of b here. And so what you realize is that when I change this value from x to 2x, and my half-life has decreased, okay, it has halved, what this means is that it is first order with respect to b. Whereas in another situation, if x becomes 2x and I realize that my half-life has multiplied by 1/4, then it will be second order with respect to b. So usually if you are given, if b is a catalyst, okay, we will have to do separate experiments where we vary the concentration of b itself so that we will be able to get the answer. Alright, so I'm going to say again, if we were to study the order of reactions, we will start by looking at whether it's a pseudo order reaction. So the one that is limiting, the one that is in smaller amounts, we will put them on the y-axis and we will look at the shape of any one graph to see its order of reaction. It's either first order or zero order. Any other things is rarely tested, right? And then finally, we are going to look at the either initial rate or the half-life method to look at the order of reaction with respect to b. So the initial rate method, it requires us to compare two different equations, right? Two of such equations with different rates by taking the initial rate, right? Or the second method is using half-life only if it is first order with respect to this a, right? So it is pseudo first order, then in that case we can use this as a relationship. So this is a very important concept. Do take some time to practice these questions, okay, because this is one of the more commonly tested questions out there.